one of the assistant directors of admission here at Rensselaer. Thank you for joining us today on Tuesday, July 14th, for our information session about electrical and computer systems engineering. We have Dr. John Wen, who is one of the department head for electrical and computer systems. And then we have Dr. Rama. I'm terrible at pronouncing last name, so I'm not going to try. Who's our director of student services from that department. So welcome to everybody. If you have any questions as we're going through the presentation, feel free to throw the comments in the chat. Your questions in the chat. It is a moderated chat, so they don't show up right away like they might normally in a streaming setting. But we'll answer one question at a time. If you have questions about admissions, ask those as well. I'll hold the admissions questions off to the end and answer those all together. But at this point, I'll pass off to my colleague in electrical and computer systems.
Thank you very much, Greg. Welcome everybody to our ECSE Electrical Computer and Systems Engineering webinar. So that's welcome to you. And these are some of the things we'll cover today. I know it's a hot summer day. It's 2 o'clock in the afternoon in the Eastern time here, and it gets really hot. So I know some of you may feel drowsy, so I won't go into huge amount of detail, but I want to give you a sense of what the department is about and whether your background and interest could potentially fit in with our department. And if you have any questions, feel free to put in the chat box. I'm here with Rama Hamanet, who's the senior student coordinator for the department, and together we'll try to answer any questions you may have. So some of the things we'll cover today is, number one, what is electrical, computer, and systems engineering? There are many electrical engineering and electrical computer engineering in the country and in the world, but very few electrical, computer, and systems engineering. So what is that? And then the next is, where do electrical, computer, and systems engineers work? So what type of work do they do? And what do you need to do to be trained as the electrical, computer, and systems engineer? And now all of you are in high school, so how do you prepare for ECSE to become an electrical, computer, or systems engineer? And I suppose you do come here, and we'll love it when you come to RTI and ECSE. What would it be like the first year in ECSE? So that's some of the things we'll cover today. So the first thing we'll address is, what is ECSE? What is electrical, computer, and systems engineering? So probably the best example is to start with smartphone. So I trust most of you, if not all of you, have a smartphone. And these days the cost has come down and the capability has increased tremendously. So you look at a smartphone and you say, well, certainly a lot of engineering has gone into the making, the designing of a smartphone. So where does ECSE, where does electrical, computer, and systems engineering fit? Where they contribute to a smartphone? So you look at a smartphone and say, okay, there's a chassis, so maybe that's a mechanical engineer. There's a screen, and the screen is very hard using Gorilla Glass on Corning, and that's materials engineering. But almost everything else you can think of is electrical engineering. So usually at this point, I will ask people in the audience, so to start naming the components in a smartphone that you can think of that are related to electrical, computer, and systems engineering. This is a list. So I posted this to a group of high school students recently, just a month ago, earlier this month actually. And these are some of the things they came up with. The first thing they came up with is central processing unit, CPU. That's a core computation unit. Of course, we associate that with computer engineering. That's a heart of a computer, of a processor. Of course, smartphone, what makes it smart is that you interact with you, so user interface, so touch screen, keyboard, voice. And without battery, we all have the experience, our smartphone dies, to run out of juice, and then it's totally useless. Then it's just a paperweight. So we need battery, and we need a charging system to keep the battery fully juiced up. Of course, a smartphone needs to you use smartphone to communicate with your family and friends through the cell connection, or through the Wi-Fi connection. So the communication and networking is also part of smartphone. The camera, we all use smartphone for camera. Cameras are so powerful these days. Of course, to store all the pictures you take, you need a big storage. Right now, it's most likely a solid state disk drive, solid state device. And you need to talk to other people, use microphone, record your own voice, sing a song to TikTok. You have proximity sensors. You got a whole bunch of sensors. So when it's close to your ear, you know not to activate the touch sensor. Of course, you need a touch screen sensor to interact. It also has something called the inertial measurement unit, or IMU, which senses motion, which is acceleration and speed, the rotational speed of the phone. So you can use it as a health monitoring device. You can put it in a pocket, you keep track of how many steps you take. And you can use as a distance sensor for focusing your camera. It has GPS, so you can localize yourself. It has facial recognition to unlock the camera. And it has speech recognition, so you can use Siri or other type of interface. So instead of typing things in, you can directly speak to it. Of course, security is important. You don't want your personal information to be compromised. So only you can access that information. Of course, we all load up our phone with tons of apps. All those are written in software to utilize the various feature of your phone. So all of those things are part of ECSE. So when you join any electrical computer and the engineering department, and in our case, and systems engineering, then you will learn aspects of all of this. These are really at the heart of the discipline. So smartphone is really a very nice motif of conceptualizing what this field is. So if you do decide this as a career, as a field you want to spend next several years in college to focus on, these are the things that you will learn, and to learn and to do. But that's not the only place, not just in the phone, that's pretty obvious. But now, of course, we all deal with, we're in the throes of a pandemic with COVID-19, and we all want to put a big X, across it. So now you usually will associate that with biomedical engineering or medical profession. But where do electrical computer and systems engineer also contribute to the combat of COVID-19? And the answer is yes. And some of our faculty actually are engaged in this area. For example, you can use ultraviolet light to disinfect. That will break down the molecular structure of virus and bacteria. So you can use that for disinfection. And you can use various type of sensors and to use signal processing to remove the noise and the bias in the sensor to detect and diagnose of whether you are infected or you may be likely infected. And the medical instrumentation, they all require some sort of processing, some sort of information processing, signal processing, sensors. All of those are ECSE. And then once you collect the data, you want to fit into a model and then use that for prediction and diagnosis and treatment That's what we do in ECSE. And the medical imaging, when you whether it's X-ray or MRI or other modality or ultraviolet yeah, or ultrasound, and this all require the skills from ECSE. And lastly, in my field, which is robotics. So now with social distancing, robotics plays an increasingly important role in clinical care. For example, in ICU, that you want robots to do a lot of routine work. You want robots to do delivery, for example, in grocery shopping and delivery, sanitation such as disinfection, and even to help with socialization. So all of those can use an autonomous device to help you care for yourself as well, and yourself and your family, as well as to maintain social connection. So all of this are what we do. So some of the examples of what ECSE, or electrical computer and system engineers, do. Now, in terms of the history of an impact of ECSE, we have a long history. The field really has its root in physics. The foundation is in the Maxwell, Clerk Maxwell, James Clerk Maxwell, equation for electromagnetism in 1860s, and that led to various applications from telephone, lighting, so all the things we're familiar with, to radio, television, and that's the early days of electrical engineering. And then comes the digital computer, and that ushered in the entire new era. And then the invention of transistor, which is like a solid-state switch, and that led to the miniaturization, packing lots of transistors into an integrated circuit. And that's started the foundation from the Fairchild, from Intel. And then in 1970s, that led to, that's like the golden age. There's a microprocessor, a digital camera, and using this type of solid-state device for power semiconductors to switch the power. And then finally networking in internet email. So I bolded some of these names and areas here because I underline our department's alumni that contributed to this transformative decade. For example, Tad Hoff is a co-inventor of microprocessor. Stephen Sanson in Kodak invented digital camera. Beligov invented IGBT, and then email, Ray Tomlinson. So our department's alumni played a significant role in the advance of electrical, computer, and systems engineering. Then in the 80s, I remember I was a student about your age. Then first saw a personal computer. You can actually have your own screen in front of you. That it was a tiny little blue screen at that, a green screen at that time. You had to load out the program using tapes, but that was a revelation. You actually have computer can do your own basic programming at your fingertip, and that was just unbelievable experience. Of course, then very quickly the world changed, and now we have smartphone. Now we're talking about Internet of Things. You have sensors all over the place. You have doorbell, that's a camera. And your refrigerator can talk to you. And then you have artificial intelligence and machine learning increasingly try to collect a whole bunch of data from all these sensors, try to infer behavior and patterns from all those data. And now, about a decade ago, 2010, a decade passed. Now all these devices are integrated into larger systems. That's where the systems aspect come in. You have smart devices, components, and now you integrate them into a large system, such as building, smart city, smarter planet, And then increasingly, the smarts are going into autonomous system, automation, the self-driving car, robotics. But at the same time, we all know that when the world is interconnected, you open yourself up to attack, to compromise. So cybersecurity is becoming very important. Now, our department is started almost right at the dawn of the age of electricity, which is we started the early part of 1900. We're one of the 3 schools that first started the electrical engineering program together with MIT and University of Wisconsin and Madison. Okay, in the middle of webinar. Okay, sorry. So we're one of the oldest electrical engineering program in the world. So the question for you guys is that if you come in, I guess you will be class of 2025 or beyond. So the hope for you guys, the ECSE class of 2025, hopefully we will list your names here for the future. Okay, but a short history. Now, so what is our field about? So our field basically has a bunch of foundation a concept of a knowledge, the spanning electronics, power, communication, networking, information, imaging, etc. And the field basically integrates them into powerful emerging applications, such as human automation interaction, artificial intelligence, machine learning, and increasingly into esoteric fields such as quantum computing, cybersecurity. So the question is, then after you go through the process of learning all these skills, where do you work? What will you do? So you will be. So this is where our graduates have some of the companies or organizations our graduates have gone on to. There are large companies such as Intel, MITRE, IBM, Raytheon, etc. And there are smaller companies as well, and that. Also national labs where our students work. Our students work in all sorts of roles, from engineers, scientists, to research. Some are professors like me, managers to direct teams of engineers, scientists, developers, particularly in software development or hardware development. Analysts who analyze data, consultants to look at challenging problems, come up with innovative solutions, entrepreneurs. Many of our graduates have gone to start well-known companies. One of the best known graduate of our department is a co-founder of NVIDIA, which is, of course, all of your GPU, the graphical processing units, are probably made by NVIDIA. Some are gone to be directors, go on more of the management ladder. Some are gone to be CEOs, CTO, even university presidents. So there are all sorts of roles, a very wide range of career path one can take. Tell you a little bit more about our department. We have 35 faculty members. We have 800 undergraduate students, roughly evenly distributed, about 200 per class. And we have 2 curricula. I'll tell you a little bit more what that means. So even though we have one department, electrical, computer, and systems engineering, there are 2 programs, so 2 curricula. One is called electrical engineering, the other is computer systems engineering. And there are, we have about 50-50 distribution, maybe slightly more in CSE. We have about 40 master students and lots of PhD students, close to 100 PhD students. And they do lots of advanced research. So the questions, I was hoping this will be have animation, but right now I guess this will just show in one slide. So frequently a student will ask me, I have interest in engineering, I'm interested in math and maybe robotics. Should I go for mechanical engineering or electrical engineering or biomedical or chemical? I hear, is based on my experience, my 30-year experience at Rensselaer as a professor, as a faculty, that seeing how students thrive, the kind of students that will thrive in our department. So you will fit in well with ECSE. If you have this curiosity of how things work, such as cell phone, quantum computer, the power system, how energy power is generated, delivered to where you are, how does LED work, a self-driving car work. If you have this thirst of knowing how things work, particularly things that draws on electricity and fairly complicated integrating into a system, that's a good starting point. This innate thirst of curiosity. And the second thing is that once you also want to not just to know how things work, but you want to make things work. Like robots, a bunch of components. How do you put it together to make it do something interesting and useful, and make it work better? How do you make a cell phone work better? To do interesting and nifty things. So again, my field is robotics. How do you put things so robotics? Electrical engineers and computer scientists and mechanical engineers all contribute to the field of robotics. But if you are interested to make things work and make it work better, then our department is a good fit for you. And finally, if you want to create new things that haven't been done before, the new circuits that will do things that haven't been done before, you will run faster and more powerful, new chips, sensors, algorithms, and finally systems, which are a collection of parts and devices and components as an integrated whole, then ECSE will be the right home for you. Okay, so think about this. Do you have the curiosity? Do you have thirst to improve, and you have the desire to create? And then the next is there are lots of things. When you apply to college, there are lots of decisions to make. So the first one is, okay, so now you choose to go with ECSE, Electrical Computer and System Engineering. But we have two curricula, we have two programs. One is electrical engineering, the other is called computer system engineering. Which one should you go for? Okay. And the fact of the matter is that these two programs are actually very close, very similar, and they both provide the fundamentals in electrical engineering and in computer engineering and in systems engineering. So they both share the commonality of ECSE. Now, but what's the difference? So there's a somewhat subtle difference for electrical engineering. Is more on the physics side. You will learn more about the physical device and system. And computer system engineering is more on the algorithm side, more towards computer science, has more overlap with computer science. You'll learn more algorithm and software engineering. So other than that, the foundation. So either one, I think could potentially fit with your interest well, but they do have some subtle differences. Okay? And it's easy because they share the commonality. It's easy to switch one to the other. Now, the next question is that RPI also offers dual major. Basically, you can, for majors, we share a lot of the same courses. You can, within 4 years, it's possible to fulfill the requirement of both degrees because you can double count the common credits between the majors. So the common dual majors are, for example, ECSE and applied physics, ECSE, either EE or CSE with physics, or CSE with computer science, or EE or CSE with biomedical or mechanical engineering. So for dual major, you'll be a good candidate for dual major if you have passion for multiple subject matters. So for people in robotics, a lot of times they'll go for CSE and computer science, or CSE or EE and mechanical engineering. But now, what's the price you pay? The price you pay is that there are a bunch of free electives in curriculum. So now those free electives will be taken up by the requirement of the other majors. And you have to be willing to work hard, extra hard. Of course, you come to RTI, it's expected you will work hard. But now you will work extra hard in order to do well in both majors. And some of you maybe have a schedule. For example, you may have college credits, just taking high school, or you may have AP credits, advanced placement credits. So you may be ahead of the curve already. Then it may make sense to do a dual major. You have two majors under your belt. But it's not I wouldn't say it's a huge advantage. You can. If you have interest in other fields, you can certainly do a minor as well. So typically it's much easier to fulfill, typically just 4 courses. And it's a good way to build background in another field. But it's not as difficult to fulfill as a dual major. So for example, so we have students do EE or CSE and economics or cognitive science, which is very hard to do in dual major, but it's easy to do as a minor. So these are some of the possible decisions, possible path you can choose. It's nothing is cast in concrete. So you can choose one, and you say, okay, maybe I don't want to do a dual major. You can always go back to a single major, or from single major at some point. You can also switch to dual major if you're early enough in your curriculum. So let's look at the curriculum itself. Okay, look at this kind of Venn diagram. So electrical engineering, computer system engineering, they overlap in the middle. So these are the commonality between the 2 programs. So there's the core, which is the computer science. Typically, it's learn programming and software engineering, the basis of that. Science and math core. These are the foundational math courses like calculus, differential equations, stuff like that, linear algebra. Science, physics, chemistry, biology. Haas is humanity and social science core, and then the core engineering courses. So these are the courses offered to all engineering students. Now, the ones in yellow, voted in the middle, these are the common set of departmental courses, ECSE courses for both program, both curricula. So introduction to ECSE, electrical circuits, introduction to electronics, computer components and operations, the basic discrete components of a computer that makes a computer, and things which are more systems oriented, probability, how do you deal with uncertainty, and things that can change randomly, signals and system, how do you take electrical and other signals, sensor signals, and integrate that with the system and analyzing the system's context. And then there are other courses leading up to the capstone design. And then there are also technical elective, restricted elective. These are electives within electrical engineering or other related fields that you can make choices. So we'll talk more about those in a minute. And finally, you have a number of free electives that you can take anything under the sun, or you can use it to fulfill dual major or minor requirements. Now, for electrical engineering, there are a bunch of courses which are specific to electrical engineering, which is different than computer system engineering. So, and these are more physical system-based, more physics-based. You have fields and waves. This is, Maxwell's equation, electromagnetic fields and waves, electrical energy systems, how energy is generated, transmitted, and stored. Microelectronics technology, this is for integrated system, how chips are made and designed. And finally, there is a lab elective that will draw on more the physical side of electrical engineering. Computer system engineering, and you have different set of required courses. And these are more algorithmic in nature. You have foundational computer science, which is more discrete mathematics rather than continuous. So very different than calculus 1 and 2. Introduction to algorithm, how do you break down a problem into a set of steps and systematically solve it with some guaranteed convergence to the right result. Data structures, and then computer, and some of these are computer science courses, and our own course about computer architecture, network operating system, and finally a computer engineering elective, which is a counterpart of the lab elective. So the core is very similar between the two curricula, but computer and systems engineering has a little bit more algorithm and software engineering flavor, and electrical engineering has a little bit of physical device and system flavor. Other than that, they're very similar. Now, yes, let's say you come to RPI and you're in ECS, you're enrolling in the ECSE department. What's your first year like? So for electrical engineering, so this is using this year as example. So in both cases, whether you're in computer systems engineering or electrical engineering, you will take some electrical engineering courses right off the bat. In both cases, you will take introduction to ECSE. So this will give you a broad overview and exposure to electrical computer and system engineering as a discipline. And there will be guest lecture to give you kind of a broad perspective, as well as hands-on lab to get you used to the practice of taking measurements and analyze data. For electrical engineering, you also take computer science 1, math, and humanities social science. And then in the spring, you'll take embedded control. So embedded control is microcontroller. You'll learn C programming and how to use program to collect information from a sensor and cause something to move. In this case, maybe a smart car, self-driving car. There's more the calculus 2 in math and physics, science elective, and that could be biology or chemistry. And then so in the core engineering, you will take CAD or engineering communication. So computer systems engineering, you also have the introduction to ECSE. So all freshmen will immediately get exposed to the introduction of the department. Again, CS1, Cal 1, that's the same as before. So these look the same, except you have the 1 credit CAD or communication in the first semester. Now, in the spring semester, you will take computer components operation, which is also required for EE, but that's in the sophomore year. But here you get exposed to the structure, the components that go into a computer early on. And then you'll take a computer science course, data structure, which is really the gateway to other computer science course, Cal 2 and Physics 1, which is the same as EE. So very similar kind of structure, but a little bit early exposure to computer and algorithm and data structure to computer science early on for CSE, and a little bit early with laboratory work in electrical engineering. Now, so as I mentioned, introduction to ECSE is a gateway to the ECSE curriculum for both EE and CSE curricula. So and what does it do? You will be introduced to the basic tools and concepts of the electrical computer system engineering. You will learn about the basic components like the resistor, capacitor, inductors. How do you construct circuits? How do you build from circuits a system? You'll learn some basic programming, take measurements, and analyze data. There will be lots of guest lectures on the breadth and the full range of ECSE research. And so starting this fall, every incoming ECSE students will receive a free data acquisition board called Adam 1000, and here is the link to that board's specification. And so this basically is a personalized data acquisition system, it's like personalized instrumentation that will allow you, and in these days of online education because of COVID-19, because of the pandemic, this type of tool is particularly useful because you can do experiments directly at home or in your dormitory, and you can bring it to the lab to debug and to use the real oscilloscope. Or you can use your computer to serve as an oscilloscope to analyze the circuit, to debug your circuits, to characterize your components. So it's a very powerful tool. Every student, ECS student, will receive a free board like this. And so it's an exciting step we're taking as a department. So every student, when you go through the 4 year of training in ECSE, you will carry this board with you like part of your laptop. Okay, so next I want to talk about how you will use your restricted and technical elective. So we encourage students to use those restricted technical electives to group it together in a focus area that you may be interested in. So we have 10 sort of nominal concentration area, so that help you to guide your selection of restricted technical elective. This can range from something more physical device and system oriented in microelectronics, photonics, power electronics, and computer hardware. These are more physical system based to things which are more systems based, which is communication and networking. That is more computer engineering oriented, computer vision and imaging. And finally, AI machine learning, that's for information processing, power system, and my area, which is control system and robotics automation. Or, if you have passion in something, for example, you may have interest in medical instrumentation, healthcare, you can design your own. You may take some courses, perhaps in biomedical engineering, or in some of these courses structured together to design your own concentration with the guidance of a faculty advisor. And the faculty in ECSE conduct research, and so they are in touch with the latest development in their field to guide you to expose you to the cutting edge research they're doing. So our faculty's research interests roughly can be grouped into 6 areas. So the top 3 are more information and systems oriented, and the bottom 3 are more physical device components and systems oriented. So the top one is control and autonomy, such as robotics, self-driving car, information science and systems, machine learning, algorithm, communication and networking, the 5G communication, image recognition, image processing. And the bottom ones are computer system design. How do you design state-of-the-art chips, state-of-the-art computer system to break the Morse, to continue the Moore's law of exponential growth of computation, electronics and photonics, and energy and power system that includes both the power grid as well as renewable energy systems. So our faculty conduct a wide range of research, and we strongly encourage students, even in the undergraduate, to participate in undergraduate research, depending on your interest. So you are in high school. You are probably mostly in 11th grade. You're junior, right? So how would you utilize your time? Right now it's summer, so some of you are probably camp counselor. You're probably taking some summer courses or whatnot. But what would be a good way to utilize your summer to prepare yourself best for your college experience? So I have several recommendations. Okay, so hopefully this will fit into your schedule. So there are a bunch of recommended reading. So these are the books from our faculty. So these 2 are fiction. So you've probably seen both are movies now. But you should read the book, Ready Player One. That's very futuristic, about kind of futuristic game, immersive game. The Martian, about astronauts stranded on Mars, how to improvise and still survive in the most barren, challenging environment. And the rest are more are nonfiction, are more biographical in nature. So this one I particularly enjoy, Empire of Lights. Talk about the early days of electricity and the competition and the race to electrify the world and make a lot of money in the process. So, for example, the companies such as where companies like GE, which was founded by Edison, Tesla. Tesla did not did not start the car company Tesla, but Tesla is the inspiration with the AC motor, AC power of the car company Tesla. Very famous, eccentric person. George Westinghouse, of course, Westinghouse is also became a major company. So the early days of electricity and how they compete and really changed the world. It's really fascinating. And we talk about Maxwell. Are we? Huh. Did I lose connection? Can you hear me? Hello? Did I get cut off? I don't see my own picture here. So I don't know whether I'm still connected. Greg? Rama? Okay, can you hear me? I don't know if I'm still broadcasting. Okay, did I get cut off? Okay. That must be it. Yeah, as we talk about, to talk about electricity, the electric storm can really cause havoc. So it's not just being useful. Anyway, so let's see. Am I still sharing? Okay, great. I'm talking the recommended reading. Yes, and this book I really enjoyed, The Perfectionist, which talks about how and really look at the intersection between mechanical engineering and electrical engineering, how we can get more and more precise, especially
yes, you did. You got cut off. You're talking about Westinghouse was the last thing I heard before you got cut off. So I'll bow out now and let you finish. Seems like there's a little bit of a storm going on outside.
To designing a chip, hard to imagine, but this book did a wonderful job weaving it together. Idea Factory about Bell Lab, the grid, talked about electric grid, and something a little bit about policy. How do you formulate policy, to regulate a major industry, and that will affect the livelihood and the path of the entire country. And certainly for fields such as electrical, computer and system engineering, math and physics is really the foundation. Lots of you take, the fact you're interested in this in ECSE is because you're probably strong in math and physics. So you should review and continue to beef up on math and physics. And programming is becoming critical. This is like language. Programming language is like a common currency now. So learning to be proficient in computer programming is essential. So you definitely learn Python programming. So many of you probably know Python programming already, but if you're not familiar, you can easily, there are so many tools online that you can learn on your own. My recommendation is just start with Python Turtle and then use this as a guide. Now, if you're interested in robotics, you should learn robot operating system. And you should learn to use GitHub, which is a tool for software to keep track of software and software revision, and is used by the open source software community. So there are some links here to teach you ROS, which is Robot Operating System, which is like the most common tool middleware for robotics, and GitHub, and tells you how you can set up. Both are free. You can just use it on your own. There are also books. Right now, I serve as a mentor of a high school 11th grade student, and he's going through this, and he can do this, already learning a lot, can write ROS to make a turtle move and do interesting things, so for multiple turtle forming, getting to formation. So you can do that too. So you can use the summer just for fun to learn programming and maybe a little bit of robotics. Okay, and if you need more help, let me know. We can talk about it. You can join the group like that student that I mentioned. Somehow I cannot go to the next slide. How do I go to the next? Next slide is not showing. So great. Control slides. Okay, got it. All right. Okay, so if you want to learn our students' experience instead of just listen to me, which I think our students have great experience, but instead of just trusting what I say, you can see the student testimonial and go to our website to listen to the students' experience. I will encourage you to stay connected with us. We have a Twitter feed. Rama has done a great job keeping a Twitter feed current. We have a LinkedIn. LinkedIn is a terrific professional networking, social networking tool, but for professionals. We have an ECSE page, and it's never too early to have your own LinkedIn page. We have a Facebook page, of course, off our website. And feel free to reach out to me or Rama if you have further questions. And we, hope that you stay interested in RPI and ECSE. And if you wanted to learn more, either about the department, about the students, the curriculum, feel free to contact us. Thank you. Okay, I see one question here.
Yeah, we have one question so far, and I think the student may have asked it before you covered it in the presentation. But when can students declare a dual major with computer science?
A dual major, I think you can declare anytime, but the earlier the better, because now you can structure your courses accordingly with that template in mind. Yeah, Rama, do you have something to add about this? Mm-hmm. Yeah. Okay, great. Thank you, Rama.
Wonderful. Anyone have any questions about electrical engineering, computer systems engineering, admissions? We got Rama and Dr. Wen here, and myself to answer any questions that you may have. If you're thinking of questions to type in, we've done a bunch of webinars before already, many with electrical and computer systems, and those are all available on the admissions YouTube channel as well. So if you want to go back and rewatch those, you can. We have dozens up there by now of all the ones going on. So if you want to look back, this will be recorded as well on the YouTube channel. It takes about a week or so for everything to process and get up there. Any other questions about electrical computer systems engineering, admissions again? Again, I'm not seeing any questions coming in, so we'll kind of start wrapping up here. We have a ton of other webinars happening throughout the summer. Everything from another electrical and computer systems information session that'll happen in August. It'll be the same presentation, just so if you really want to watch it again, you can. We have every single engineering department is doing webinars throughout the summer as well. So we've done mechanical engineering already, material systems engineering. We're setting up other ones as well. And then we have our daily information sessions for admissions Monday through Friday. Mondays, Wednesdays, and Fridays are at 3 p.m. Eastern Time, and Tuesdays and Thursdays are at 7 p.m. We also have our summer visiting days, and those include a short information session from an admissions counselor, and then a faculty panel that'll be available. The first one is on Monday, the 20th. So feel free to sign up for that one as well. I'm not seeing any other questions come in. So Dr. Wen, Rama, thank you for joining us today. And if you want to say goodbye, go right ahead.
Yeah, thank you very much. Yeah, thank you for